Hello, and welcome to the ASDRP Researcher Interview Series. Today, I'll be talking with Ashwin Prakash. Thank you so much for being here today. How are you doing?
I'm doing great. Thank you.
Awesome, I'm glad to hear that. Um, to start us off, I would first love to know about how you found out about ASDRP.
So I actually found out about ASDRP by talking to a bunch of my friends who had done the program in the past. A couple of my senior friends actually recommended the program. They said that it was an awesome experience and that they learned a lot. So when I heard about it, I checked out the website and I decided to apply.
That's awesome. Very cool. What high school do you go to?
Yeah, so I go to Foothill and I'll be a rising senior in the fall.
Awesome. Where is Foothill?
Foothill is located in Pleasanton, California.
Okay, very cool. We have so many researchers from all over the Bay Area, from north and south and all over the place. How long have you been researching at ASDRP?
So I actually just started this summer, so it's been around a month or two that I've been researching an ASDRP. My research group has gotten together recently, and we've been working towards the introductory phases of our project.
Okay, very cool. Who's your advisor?
My advisor is Dr. McMahon.
Awesome. And what project are you working on?
So our project is essentially using game theory in order to minimize traffic collisions at intersections. So it involves a decision-making algorithm in regards to autonomous vehicles where we implement game theory logic in order to sort of minimize the amount of collisions that happen at traffic intersections and optimize like traffic flow patterns and overall just like improving the flow of traffic at intersections.
Wow, what a fascinating area of research. So you're working, is that more on self-driving cars like you mentioned, or is that
Yeah.
like in general?
Yeah, so it is specifically in regards to self-driving cars. So we are using a bunch of different ways to achieve this. So our main project involves using the Raspberry Pi as a medium to communicate between two different cars. So our plan right now is to build multiple buggies using the Raspberry Pis and actually model real-life simulations of the intersections. So what we plan to do is that we plan to have these Raspberry Pis communicate with each other via game theory logic to say, hey, which car needs to go at the intersection? Which one, what's the safest option? What's the most optimized option at the intersection? And game theory is the basis of which we're going to establish like this little scenario in which we have the cars at the intersections. Um, so yeah, that's essentially what we're working on right now.
Very cool. And would you mind explaining a little bit more about what game theory is?
Yeah, so game theory is essentially like a way, it's essentially a process in which you can make decisions that are most optimized. So according to the official like definition of it, it's a study of mathematical modules of strategic interaction between irrational agents. But there are, in regards to our project, we're using game theory as a way to see what is the right decision to be made because in an intersection, we're going to have cars, and in this case, we're going to have Raspberry Pi buggies that are positioned at different points along an intersection. And so when a car needs to make a decision whether to move or not, they need to be able to easily determine, is it safe for me to move and am I going to get to the destination on time? And so those are generally the two main factors you have to consider when using game theory logic. One, you want to always optimize the safety. This means you're obviously not going to crash into the other car. And the second thing you have to really factor in is you have to make sure that you're actually getting to the destination in the most optimized way. That means that you can't be swerving around an intersection. You can't take a wild path just because you want to get through, because that's both unsafe and non-optimized. So yeah.
Okay. Wow, that's really interesting. And so the Raspberry Pi buggies, are those actual autonomous cars or are those just a model or are they like a model car?
Yeah,
How does it
so
work?
so essentially they're going to be prototypes of self-driving cars, or like you can call them little like experimental units, because we're essentially going to build them and we're going to find a chassis kit. That's what my team is working on right now, actually. We're starting to get together and assemble the materials so that we can actually get building them. But these buggies are going to use the Raspberry Pi as their main processing unit. They're going to involve all the other components like motor drivers, the DC motors, the wiring, the breadboard, all of that, along with the main component, which is the ArduCam, and that's going to be our main processing unit. The ArduCam is essentially a mini camera, and there's a bunch of libraries we can work with, such as OpenCV and NumPy, that'll allow the camera to be able to use object detection in order to do the game theory process, game theory processing, like I spoke about earlier. So the Raspberry Pi and the whole car are going to be miniaturized versions or miniaturized experimental examples of what cars would look like at an intersection. But the main emphasis on our project here isn't the cars itself, but it's more the logic, using the game theory logic in order to build an algorithm that reduces the amount of collisions at an intersection.
Wow, what an involved and amazing project that is. It's really cool that you are getting the chance to work with both data and then like the physical model of the cars. That's really awesome. So you talked a little bit about this already, but what does a day in the life look like for you as a researcher at ASDRP?
Right. So usually there's a bunch of different things I have. So right now, like I mentioned, we are in the introductory phases of the project. So we finished a research proposal couple of weeks back, and now we're working on assembling the materials. But essentially, there's a bunch of great experiences that ASDRP offers, like the colloquiums, which are really awesome and all of those things. But with regards to my specific project, we have team meetings bi-weekly and sometimes tri-weekly. So these include meetings with just our own group. We meet on over call, and we discuss like a bunch of the different ideas and process and plans that we have for the project. And then we also have group calls with Mr. McMahon or Dr. McMahon, who also helps us and guides us in the right direction and gives some of our feedback and suggestions on our idea. Like at one of our most recent meetings, he was talking about some of the ideas on our project proposal and some areas that could use work, which we decided to revise. So yeah, as far as the daily life, through daily meetings with my and bi-weekly meetings and some work on our own, like a lot of research goes in. For example, like I've spent a couple of hours here and there almost every week working towards understanding the concept of the project a little bit better, because when we came across it originally, I didn't know that much. So it was a lot of research and time I had to put in towards really understanding the project well. I come from more of a hardware sort of background where I've worked with a lot of the physical hardware components of a robot. So I did a lot of learning on the software side, and I've learned from a lot of my group mates as well.
That's awesome. It's cool that you're bringing that experience
Yeah.
to the team, and it sounds like a really awesome collaborative environment, and I'm glad that it's been such a good experience working with your peers and also the advisor.
Yeah.
Would you mind talking more about your team and what it's like working with them?
Yeah, so my team is composed of a lot of awesome individuals. They're all, I think what makes them so great is that they're all really passionate and enthusiastic about the project. Every meeting we come like, we don't, it's not like a formal interaction where we're all like down to business. There's always jokes and we're always having fun while doing research. And I think that that's what makes our team so great. They're always interested in making our project succeed and doing better. So everyone has a passion and they're all willing to be here and they're all excited to be here. So I'd say that that's a great aspect of our team. I think we work pretty great together. We've accomplished a lot in the weeks that we've been researching, and we're always super productive with our meetings. And I think that it's just an awesome experience working with our team. They're an awesome group of individuals. They're friendly and really kind. So, and knowledgeable at that too. So yeah.
That's really wonderful to hear. Yeah, all of you researchers are so amazing, and that you're able to juggle your regular schoolwork on top of these complex research projects as well.
Yeah.
So it's really awesome.
Yeah.
What has been one of the greatest challenges that you've encountered so far in your research?
So originally, this is actually an interesting question because there's actually been multiple challenges we've come across. So when we came across, I think the initial difficult phases of our research was really, I guess, understanding how we're going to implement the game theory logic into code. And that is sort of the basis of our whole project. And that's something that we don't entirely know how to do, but we're working towards as we speak now. So the concept of implementing a game theory logic, we looked at like mathematical models and other papers and other research papers published in the past. And these gave us sort of an insight on how researchers used game theory, not with the regards to like just autonomous cars, but also in other areas in different sectors in tech, and how game theory logic was sort of implemented, and all the formulas and the mathematical representations that go with it. And I'd say that was the sort of tough part because, you know, as high schoolers, we were working towards understanding it, but a lot of the mathematical models were really confusing at first. So it was a lot of time and effort we had to put into understanding how they worked. In particular, a couple of papers gave a couple of formulas that we didn't really understand at first. So we got together over a couple of calls and we were able to piece them and sort of visualize how we're going to implement them into our project.
Wow, that's awesome. That's really amazing problem solving that you guys are doing. And I've heard that the math, it seems to be like a theme, is definitely a challenge.
It is, yeah.
Especially because I'm not sure how much like high level calculus people get to do in high school, which I would assume is probably is that part of it? Is it a lot of calculus or is it more algebra? What is that like?
So yeah, I'd say it does involve not so much calculus, but it's more like logic-based math.
Okay.
It's a lot of sets and series and sequences that you need to understand. And it's more algorithmic math. So like it's just very logical. So it's hard to put it other than that. It's not complex math to the point where you need like calculus or high level math to understand it, but it's just high level logical math. Yeah.
Okay. Yeah, that makes sense. Nice. Um, well, now that we've talked about the challenge, what have you found to be the most rewarding so far?
I'd say the most rewarding aspect is just being able to learn from my teammates a lot of stuff. So like I said, I personally don't know a lot about the software. I come from like more hardware standpoint. I've done a lot of robotics in the past. I've worked with motors, and yes, I have worked with software, but some members of my team are really knowledgeable about CS and stuff. So it's great to learn from them and understand a lot more about the subject from them. It's I think there's a lot I can take away from my teammates. Like they're not only knowledgeable, they're really hardworking and all of that. So I think that's a great experience working with them. Another great experience overall in my project is just like, I mean, doing something I sort of enjoy doing. ASDRP sort of gives me a medium to work on robotics and stuff. And I've always been interested in robotics from a really young age. So working on it on a project that's more impactful than anything I would be able to do just at home or working on my personal projects is really awesome. So I think that's what it is for me.
That's wonderful. I'm so glad it's an outlet for your skills and creativity.
Yeah.
That's super cool. Um, where do you see your research going next? What are you excited about exploring with this project?
Right. So we're actually we're pretty excited about the next step in our project, which is really the data collection. So we were on the introductory phases, the pre-work, sort of getting to know the project more, and we'll still get to know the project more, but now we're sort of at the phase where we can start working on building the buggies and actually testing and working on the code. So I think that's what's up next. And that's the real exciting part. That's the real research aspect that we're looking forward to.
Awesome. Nice. And then on a broader scale, like a more broad question, do you feel as though your research has changed anything about the way that you view the world?
I'd say, yeah, I think it has, it's given me a lot more insight into not only research, but like the way that just generally like you see how experiments and stuff are conducted. I think it's given me a mindset of a researcher in the fact that you understand how difficult it is to do all the trial and testing and all of that for every single product. And there's a lot of complexity that goes into the products you see in everyday life that we don't really see in our lives. So, I mean, even just understanding the intricacies of a car, the basic like autonomous vehicles, just now it's really expanded my sight into how complicated and how fascinating they are because they're just so expansive and such complicated systems. We don't see that in our daily lives, but yeah.
Definitely. That's a really good point. Yeah,
Yeah.
that makes sense. And then before I ask my final question, is there anything else that you'd like to say or any like fun stories or interesting things you'd like to share?
Um, uh, Funny stories. I wouldn't say we have any funny stories, but it's just it's pretty fun. I mean, honestly, just to recount my experience at ASDRP, I wouldn't. It's really, I would say it's a great learning experience and it's been very fun. I don't think there's been a single point where I've been like bored the summer break because I've always been up to work with ASDRP stuff. And even when I find free time, I always find myself gravitating towards doing work for the ASDRP because I'm interested in the project so much. But yeah, I think it's just been a great experience. So yeah.
That's super cool. That's great to hear. Okay, and so for my final question, I would love to know what advice you would give to a future researcher looking to join ASDRP.
I'd say the most important thing is finding a project you love. I came into ASDRP. I wasn't really sure what project I wanted to do. I joined, I asked a couple of advisors and I ended up with Dr. McMahon. So I was pretty happy and pretty excited to be working with him. But even then, I didn't really know what area I wanted to work in. Um, I actually didn't do a lot of experimentation, and I think this is probably something I should have. I probably should have explored more of the groups, but I did join the AB group, and that's a decision that's worked out really well for me. And I think that's probably why I like the project so much. I'm interested in a lot of science stuff, but I'm sure I wouldn't even be half as interested in some of the other topics they were doing, just because it didn't appeal to me and my interests. So I think if you can find the right project in ASDRP that's sort of personalized towards what you like and what you love to do, that's probably what you want to do in a project.
Awesome. That's great advice. Thank you for sharing that. Yeah, it's the diversity of projects is really cool to hear about. I talked to one researcher about mussels and microplastics, which is just on another side of science than autonomous vehicles. So that's
Yeah.
super cool. Well, thank you so much for joining me today. It's been wonderful talking with you and learning more about yourself and your research. And good luck with everything this summer. And I hope you have a wonderful rest of your day.
Thank you. It was awesome doing this interview.
Thank you. All right. Bye-bye.
Bye.